Okay, we're going to talk today about wave data and how to interpret some of the basic graphs that are publicly available on the CDIP website. CDIP is the Coastal Data Information Program that's run out of UCSD, University of California in San Diego's Scripps Institute of Oceanography. Just jumped right in. This is the actual buoy. Most of the wave data, actually all of the wave data that CDIP puts out there comes from surface buoys. This is one of them, which is a buoy manufactured by a Danish company called DataWell. That's the picture of the actual buoy itself at Beacons. All of the data that I'll be talking about is from this particular buoy. Today, that's the Beacons Beach out there. For those who are familiar, that's the steps heading down to the Beacons. There's a parking lot there at the top. So you can see the buoy is pretty close to shore. This picture is actually taken when it was installed a couple years ago. A few years ago, I don't remember exactly when, but not on the day they actually, I collected was there filming it. And so I was there on August 10th at 8 o'clock in the morning for a surf session. And then, again, this is at Beacons in Leucadia, which is part of Encinitas here in San Diego County. This is just a video. You can see the buoy right there in the middle of the frame. You can see actually some dolphins over there. Cool. So you can see the buoy is pretty close to shore. And first thing you can actually take a look at here, you see that it's pretty flat out there, right? Very little energy, almost nothing happening over there. And you can tell there's not a lot of people that line up either, right? But if we kind of freeze that frame there a little bit, and then one thing that we can do is you can see that there's a couple of different wave trains that are very readily seen here. One wave train kind of show that it comes in from mostly from the south, right? These directions over here. And then one more intense that's coming in from just north of west, which is, again, we're going to go back here. You can see I just drew a line along where those waves are. This is the parking lot at Beacons where I was looking straight out, which, and the shoreline runs kind of northwest to southeast. And so that puts west basically in this direction over here, perpendicular to the beach, right? So again, point here is that you got two main wave trains coming in, one from this kind of direction over here, and another one slightly north of west. And now we can actually look more at the data itself. So kind of throw that image back there so we can reference to as we go along. First thing, this is a polar plot, which shows the amount of energy out there for what we call the burst. The burst is basically just a sequence of about 20 minutes over which the buoy is collecting data and then processing that data to compute the statistical estimates, which are what we see as the actual wave, the height, the period, and those things like that. So in a polar plot, the north is at the top here. So 360 is north, that is east, and then south and west. The distance from the center of the plot to the edge is the decrease in period. So see this ring here represent 20 seconds, 12 seconds, and so on all the way to 4 seconds over there. And then the sort of the intensity of the blob based on this scale. Don't worry about these funky units here. We can talk about that in another video. But the intensity of this color, the closer it is to red, means the more energy in it. But not a whole lot of red over here, right? As you can see from the photo as well, very flat conditions over there. But the main point here is that there are indeed two main wave trains. One over here, this is centered just, sort of in from the 8-second ring. So let's say this is about 9-second coming in from about 210 directions. And then so this blob here correspond to those waves that are coming in from this direction over here, the ones that I had drawn lines here. This blob here with more energy are the waves that are coming in from like these wave trains out here, right? And they're coming in just as we see in the photo. They're coming in from just north of 270 or north of west over here. So again, this plot very helpful in understanding what's actually going on out there. See a little bit of a longer period, but very, very low energy swell coming in over here from this particular reaction. Almost completely, I would say completely unnoticeable there in the actual photo or the video. Another of the data products that you get out of the CDIP website, which is the actual wave statistics themselves. So you have significant wave height, which is the average of the highest 1/3 waves. Peak period, which is the period where most of the energy is concentrated for that particular burst. The peak direction, which is the direction where that period is focused in, and then the average period over here. Periods are measured in seconds. The directions in degrees based on this compass rose over here, and then the significant wave height I've had here in metric. Sorry for those who are familiar with English units, but here in meters. This data was collected on August 10th at 8 a.m. local time, which is 15 or 3 p.m. on UTC time, and that's what UCDIP uses. So that roughly coincides to right about, so that's 13. So that'll be roughly about right here, okay, in the plot. And so again, like you see, very low waves, right? I don't think it gets a whole lot lower than this, than about 1/2 meter out there, which is a couple feet, right? Just if you just eyeball here, this is roughly what you're seeing. Come down over here, you see the wave period is kind of bouncing between these two numbers here, the peak period that is, and that's because for one burst, which is each one of these little dots, sometimes this blob has most energy, and sometimes this blob has more energy. And so the peak period actually bounces between those two parameters until eventually settles down to one particular one once the sea gets more developed. Direction as well, they're similar. Again, sometimes this direction has more energy, sometimes this direction has more energy. So it kind of bounces up and down a little bit around those two. Nice thing about average periods, because it's an average of all of these, so there's less of actually bouncing up and down. But what happens over here is that you're kind of biasing low a little bit, if you will, because it's taken the average of all of these data here. The nice thing I actually like to look at it is another product that they use, is separation between sea and swell, which is what it means is that basically you take all of the data and anything that is 10 seconds or less, you make it, call it at sea, and everything that's 10 seconds or longer, you call it swell. And so what you want, if you want to go out there surfing, is that you want the swell line, which is that blue one, to be above the sea line, which is not, again, this is when it was taken over here, this particular time, which is not what we're actually seeing here, which is in just the opposite. The sea line, which is the green one, is above the blue line, meaning most of the energy is sea, which is this small chop that we're seeing over here. Okay, so if you want to go surf and you want to go look at this particular plot, you want to make sure that the blue line is above the green line. Again, it doesn't mean that we can't look at the data and we can't surf it. It just means that that's what the conditions are going to be like. Most of the energy is going to be on the sea rather than swell. And sea, you can think of it as like those smaller chops that are created in the beginning of a storm, or that are created, when an initial wind begins to blow. Whereas the swell is the more developed, where the wind has blown over a longer period of time and distance over the surface of the water, that then's created those longer period swells. And typically comes again from energy systems that are way far off in the distance. This is where you can actually get the data from. So if you just go to cdip.ucsd.edu, that website there will take you to this. There's tons of information over here that you can look at, all sorts of different graphs from all of the different buoys in different systems that they operate. If you click on station map here, that will take you to where a map of all of the stations that they operate. Most of them, of course, are along the coastal U.S., but you can see their stations throughout the Pacific as well. I'm going to zoom into where the Beacons buoy is. For those who are familiar, you're going to see it already right there. And if you just click on that one, that will take you, this little message pops up. You click on data, and that will take you to the actual where the buoy's web page is. Lots of information here, lots of graphs, and you can look at this in all sorts of different ways. But that's where you can go and actually go and take a look at some of the data that I was just talking about. And that's it. Now we can actually go in and look at what surfing these waves actually looks like in that particular day.
Maybe.